If you look at guys, if it is an instance method, what do you need? If it's an instance method, to access this method, you need an object, correct? But can you create an object of this class outside of the class? No. That means you cannot access. The only way is by making the get instance method as a static method, you can access the object of this class, right? So that is the reason we are calling a get instance method. I call 3 times, and if I run the program, I'm getting the same hash code. That means I am new object is not created. We are using the existing object only, correct? So this is what we have seen yesterday. Now let's look at today. Yeah. So here, the way of creating an object like this is called as eager initialization. Eager initialization. So why it is called eager initialization? Let's look at. So there is a singleton design pattern class I have written. For example, I am not using this. I'm not calling this get instance method anywhere in my application, but still the object will be created. Am I right? Because it's a static variable will be loaded during the class loading time. That means whether someone needs the object of this class or not, you are creating one object every time when the class is loaded. Is it right approach?
No.
No. So that means you don't see the problem. This so there might be a question in the interview that what is eager initialization in the singleton design pattern. So you have to mention that eager initialization means, so in the singleton design pattern, we write a private constructor. So the only way when we have a private constructor, the only way is we can create a object. Now we can create a static object creation like this. This is called eager initialization. The problem with the eager initialization is even though no one is calling the get instance method, still you are creating a object. That's the problem. So that means even though nobody is trying to use this class or use this get instance method, you have a object. That means it's of useless, right? So that is the reason they go for lazy initialization. So lazy initialization, see, this is a eager initialization. So you should not use eager initialization. You should go for lazy initialization. Let me tell you what is lazy initialization. So that means lazy initialization means you don't create a object here, correct? Now here, this is called lazy. Okay. Now here I just initialized it to null, right? But now when I should create a object, when someone calls this get instance method, correct? So then what I will do? Return s equal to new singleton. So let me create a object inside this class, inside this method, s equal to new singleton pattern, and then return s. In this way, you guys tell me when the object is created during the class load time, does the object will be created? During the class load time, what is the value of the reference variable? It is null. So will it create any object? No. So when the object will be created? Whenever someone calls this get instance method only. Now let's go here. So here when you call the get instance method, it is creating an object. Again, when you call the get instance method, it is creating an object. Let's run the program. Now, see, it is now the hash codes are different. That means, am I getting a one object or multiple objects?
Multiple.
So that means, am I breaking the singleton design pattern?
Yes.
Yeah. So what that means, where is the problem? Whenever you're calling a get instance method, it is not checking whether there is already an object or not. It is not checking. It is simply creating an object every time. That is wrong, correct?
Yeah, it
So
should be a conditional basis. Yeah, right.
yeah. So can I say that if when should I create a object? When s equal to null, correct?
Yes.
Whenever the s equal to c, whenever you load the class for the first time, the value of s variable is null. Then when you call the get instance method for the first time, the s equal to null, the condition is true, then it will create a object. Done. One object is created. Now whenever you call from here again, is the s value is null second time whenever you call the get instance method? No,
No.
it's no longer null because it's a static
Yeah.
variable, correct?
Yeah,
And a
correct.
class level variable. So It will not be null, so it won't create a new object, correct? Now let's run the
Yes.
program and see. See, you can see I got the same hash code. That means even if you call multiple times, it won't create multiple objects. Let's debug and see. Debug as Java application. So see, first time whenever I'm calling get instance method, the value of s is null. So when it is null, it will go inside it and it will create a object. Done. See, I got the hash code. Now second time when it's calling, see what is the value of s? You look at it is no longer null, correct? It's having a reference because why it is having a reference? Earlier you created and it's a global variable, correct? And it's a static variable. Static variable will occupy the memory only once, correct? So that's the reason it is no longer null. Look at here. Earlier I can see null, but here now it's an object. You can see the hash code is also present. So it will not go inside it. So it will return the same object. So that means that is the reason same hash code. Now, earlier when I run the program without condition, I got multiple objects. But now did I get multiple objects? Or did I get
Same.
multiple? Only same object. That means I am satisfying the singleton design pattern. So this is what a basic singleton design pattern code. Now, let us understand there are different ways to break the singleton design pattern. I repeat, there are different ways to break the singleton design pattern. So one is reflection. So what is reflection? Can someone tell me what is reflection?
Seeing the same image.
Okay, that's about English, but in Java there is a reflection API, right? What does it mean? So in Java there is a reflection API. Using the reflection API, what you can do is, see, whenever I have a private constructor, here I have a private constructor in this class. Now whenever I have a private constructor, can I create an object?
Through reflection API can possible, I think.
Yeah, but without reflection, can I create?
No, no,
No.
sir.
So because that means whenever you have a private constructor or private variables or private methods, you cannot access those outside of a class. But using reflection, you can access. I repeat, using reflection, you can access the private constructor also. How? Let's see. So this is the way to write the code for reflection. So that means I will write a code with a reflection and I will try to get an object. So and I will see the hash code of provided by these three lines and the new instance hash code. If it is same, it's the same object. If it is a different, I created a one more object. That means I am breaking a singleton. Let's see that. Singleton dot class dot get declared constructor. Yeah, I don't need to pass anything because I'm calling a default constructor. Throws. So no such method exception or security exception. So let me quickly copy this code. I mean, it's a simple code only without wasting any time. Then we need to set one set is accessible equal to true. Yeah, the same thing. So here singleton design pattern dot class dot get declared constructor. Now this will give the constructor object. So I will put this into yeah, let's do control shift O. So this you need to have this import. Now set accessible equal to true. And then so whenever you call this get new instance method on using a reflection, what it will do? It will call the private constructor. And from this line of code, you can see what is the hash code. Okay. From this line, from the line of new instance, what it will do? It will call the private constructor. And whenever it is calling a private constructor, whenever the constructor is called, what does it mean? it has created an object. Let me write a system.out.println so that we can see. Hi, constructor is called. Let's put a breakpoint here. Let's run the program or debug the program. Debug as Java application. See, first time get instance method. Constructor is called and the object is created, correct? So next time, whenever you call the get instance method, the object is no longer null. So it won't call it will return the same object. Third time also same thing. Now what I'm doing, I'm calling, these are reflection code. So using reflection, what you can do, whenever you say that class name dot class get declared constructor, this is a method available in the class called class. There is a class called class in Java. See, there is a class. See, there is a class called class in Java, which has get declared constructor. See, you can see, right? Get declare methods, declare constructor, declare field, declare public methods, constructor. So using these methods, you can access a private variable, private method, private constructor, public method, everything you can access. That is what the reflection API. It's a core Java topic. Now, let's go from here. Set accessible equal to true. You need to set it, then only it will call the private constructor. So now from this new instance, see, from the new instance line, as I mentioned, from this, whenever you call the new instance, what it will do, even though you have a private constructor, this using reflection API, you can call the private constructor. Look at here. I'm not getting any compilation error. And do you see? My control went into the private constructor, correct? So that means using reflection, am I calling the private constructor?
Yes.
And whenever you call the private constructor, what will happen? Whenever the constructor is called, what happens?
Object will be creation.
Object is created, right? Now let's see. So let's go to next line of the code and see, put a breakpoint. Yeah. Now here, if the same object is returned, then I should get a hash code, same hash code, correct? But if I'm getting a different hash code, then what does it mean? It has created a new object. Let's see. See, did I get a same hash code or different hash code?
Yeah, different.
So that means how many objects I was able to create now?
Uh, hmm.
Overall
Two
two,
object.
correct? This
Oh,
is
yeah.
all this by using a get
Uh,
instance method is one, and by using this one. So for example, let us take the scenario. Let's take names. Rajesh and Shankar and myself are working in a project. Now, this is what Rajesh has. Let us take that Rajesh has written this code. Okay. Now, so Rajesh say that this is a singleton design pattern. Whenever you want to use this, call the get instance method. Done. But what Karthik has done? So I know reflection. So using reflection, am I able to create one more object?
Yes.
Yeah. So, but so by creating by Karthik, when Karthik has written this code, so what does the Karthik is doing? Can I say that Karthik is breaking the singleton design pattern code that is written by Rajesh?
Yes.
So that means you are creating a new object. Now, what is the fix Rajesh should do? So Rajesh should do something inside this class. Rajesh should not allow anyone to create a more than one object. Agree? Yeah.
yes.
So what you do? If inside the constructor, can you write if s equal to null, then only create a object, correct? If s not equal to null, what I will do? See, whenever you are calling this time, for example, whenever you call, see, that means basically what Rajesh is telling, use get instance method only to get a instance of this class. Even if you try to do the reflection API, the new instance method will call the constructor, and here he can check if the s not equal to null. That means the object is already there. Then what do? Return new exception. That means we are throwing exception. We are not allowing anyone to create a object even though you are calling a reflection, correct? Object already present, correct? Sorry, not written, it's a throw, my mistake. Throw new exception, add throws. Okay, so what we are doing now, let's run the same code. Let's run the same code. Let's add the throws keyword. Debug as Java application. See, first time s equal to null, it has created a object. So see, whenever it is going to see, whenever you say like this, it will call the constructor. The constructor is created, but at this time s equal to null. Null not equal to null. So it did not throw any exception. This system.out.println is called done. The object is created. Now whenever you say get instance method again, it won't create a object. See, same hash code. Now let's go to the this one. What was is happening? Whenever you call this using reflection, whenever you call new instance method, it is calling the private constructor. Yes, but whenever you call the private constructor, by that time already the s value, what is the value of s? Already it is present, correct? When when there is already object and someone is trying to, Karthik is trying to break the or call the private constructor and to create a new object, what Rajesh is doing in the constructor, he has written a code that if the object is not null, then throw the exception. So then what it will happen? It will throw the exception. So that means does the object is created?
Oh.
See, it will throw the exception. That's it, right? That means, do you think the object is created?
No, sir.
No. So that means what Rajesh is doing? No, Rajesh is making sure that no one can break his singleton design pattern, even though if someone is trying with a reflection, correct? You guys agree with me?
Yes.
Any questions? So there are multiple ways to break the singleton design pattern. One of the way is using reflection. Using reflection, you can break the singleton design pattern. But so this is the code that you are breaking. We have seen how to break it. Now later, what is the fix? So in the constructor, what do? You create a object. If the object is not null, throw the exception so that you will not allow anyone to create a object. Okay. So any questions or shall we move on?
Sir, sir, line number 9 and 12, 14. There is
9.
no, yes. For example, there is no that 3 lines only. Directly we can write the 20 and up to 24 only. Then we will create the object, right?
I could not understand.
Sir, line number 10, right? Line number
Yeah, correct.
line number 9 and 12 and 15.
Hmm.
For example, not available this code, sir. For example,
Okay.
even only reflection API is there.
Hmm.
Then this
No.
case will create
So
the
yeah, no. The thing is, singleton design pattern when whoever is writing. So
okay.
why they are providing this get instance method? I understand your question. If this code is not there, then
Yes, yes,
reflection will create a object. Yes, correct. But even
yes,
though reflection is created, how many objects are there? Only one, correct?
yes,
Now,
yes.
if you write this code after this reflection, then also, does the get instance method will create a new object?
It instance, right?
No,
Yes.
no. It
Oh,
if
okay,
s
okay.
equal to
Yes, yes.
null only, it will create.
Yeah, yeah,
So
yeah.
whether you move it front or back, at the
Okay.
end, how many objects do you have?
Only one object only.
Only one, correct?
Yes, yes.
Yeah. So now the thing is, why should we should not allow? So say whenever you are writing, why did you create this get instance method? Because you have written a private constructor. Everyone will not be able to use a reflection, correct? Some people may know, some people may not know, correct? So you are providing a get instance method to make them life easy. So that call this method and you get an instance, you don't need to scratch your head, correct?
Yes.
So if someone is so technical, and then only they will use this one. If they use, instead of calling the get instance method, I mean in the entire container, the object is not yet created, but you created a object using reflection, then S will not be null. So the object will be created. So at that time, S is equal to something value. Next time onwards, when someone is calling the get instance method, will it create a new object? No, correct?
Yes.
Because we have a condition here. When the object will be
Yes.
created, when S equal to
It's
null
equal
only,
to
it will
null.
be created, right?
Yes.
Okay. Now let's look at, there is another way of what are the different ways to create an object in Java? Different ways to create object in Java. One is class name,
Equal. Yeah.
ref variable, reference variable equal to new class name, correct? This is
Yes.
one way. And second way is reflection. We just now seen. The
Yes.
third way is cloning. Do you remember? By
Yes.
using
Yes.
cloning also, you can get a new object, correct?
Yes.
Let's do the cloning and see. So in order to do the cloning, what you should do?
Cloned method is there, sir.
So clone method is present in which interface? Where the clone, sorry, not interface. Where does the
Object
clone
class.
method is present?
Object class.
Yeah, object class is having clone method, correct? It's a protected method. Now, what is the accessibility of a protected method? If it's the same package, you can access within the class with the subclass, everything. But say if it is a different package, say object class is present in java.lang package. My singleton design pattern is present in com.vikram package, correct? So now these are
Yes.
different packages. Now, how can I use the clone method? By overriding it, correct?
Yes. Yeah.
Yeah. So let's override the clone method. So I have overridden the clone method. Then I'm just calling a return super.clone. Let's run the program and see. How can I call the clone method?
Class name.
S3, you take any object, correct? Existing
Yes.
object, S3.clone. And see whether, so it should create one object, correct? Let's see whether it is
Yes.
creating an object or not. S8 equal to S3.clone. No, and so we should, yeah, I'm just casting it. Yeah, done. Now let's print it. This is out S8.hashcode. So let's put a breakpoint, but let's run the program first of all. See, okay, let's comment this reflection code because from here it is breaking, correct? So
Yes. Yes.
let's, what I will do, I will try to put it in a try catch, so that try catch. So if there is an exception, it will come here and then it will go to the next line, correct? Let's run the program. Yeah, see, I got some clone not support exception from line number. See, from line number 34, whenever this is called, I got some clone not support exception. Why? Does anyone know how to do the cloning in Java, core Java? Whenever you want to do the cloning, you have to override the clone method, but
Yes.
you need to implement one marker interface, right? Implements clonable, right? You remember?
Yes. Yes.
Clonable, yeah.
Implements clonable.
Clonable, yeah.
Clonable is not a, does the clonable has any abstract methods?
No.
No.
No, sir.
A interface which does not have any abstract method is called as marker
Market
interface.
interface.
Yeah.
Yeah.
So now many people will get a doubt. Whenever you are implementing a clonable interface, you need to override the clone method. They might think that this clone method is present in the clonable interface, hence you are overriding. Is that true?
No, sir.
Now, where is the clone method is present?
Object
In the
class.
object class. Why are you overriding it in the singleton design pattern class?
To create the
Because,
object.
no, because the clone method, the provided by the object class is what kind of a method? Protected method, correct?
Yes.
So what is accessibility of a protected method? Within the same package, you can access anywhere, subclass, parent class, everything. But what is the package in which object class is present? Java.lang package, correct? And what is the package in which my class is present? Singleton design pattern, com.vikram. Now, are these two different packages?
Yes,
Now, whenever you have a different packages, how do you access the protected method? By overriding or by creating an inheritance, correct?
correct.
So if I am accessing only within the class, I don't need to override it. But I am accessing this method outside of a class, correct? Outside of a singleton design pattern. Hence, I need to override it, correct? Now, whenever I override it, let's run the program. See, from this line number 35, I got. Now let's debug, if not. Debug as Java application. So now let's. So see, from this line number 8, what I got, hash code is different. That means now, am I breaking the singleton design pattern or not by using cloning? I got a different hash code. What does it mean? Sorry, let's execute. See, from this line, I got a different hash code. What does it mean? Does it created one more object?
Yes, sir.
So that means earlier I was able to break the singleton pattern using reflection. And then by adding a check if condition in the constructor, I fixed it. But now similarly, by using a cloning also, can you break the singleton design pattern?
Yes, sir.
Yes. Now, how do I fix it? Now, whenever you call the clone, dot clone, it will go to your class overridden method, correct? Yes or no?
Yes, sir.
Now here, what is the code that is present? Return super dot clone. That means it is going to super. What is the super class for this class? Object class, right? So object class clone method, what it will do? It will create a new object every time. So then what you should do here, whenever someone is calling the clone method, you don't call the super, you just return. Whatever the object that is present, you return that, correct?
Yes, sir.
So in that way, will I be able to create a new one more object? Let's run the program. See, always it is giving the same hash code. That means how to fix the singleton design pattern when you are using a cloning. You need to write, you need to follow the deep cloning, not the shallow cloning, correct? So shallow cloning, by default, shallow cloning, Java follows the shallow cloning. Uh, I mean, you need to write the code in the clone method. By default, the clone method will call the parent class clone method, return super.clone method. You should not call that. You just return S. What is S? Whatever the object that is present, if it is available, you give it. If it is not available, you can write a code, right? If the S equal to null, then only create a object, correct? If S equal to null, then return, create S equal to new singleton like this, correct? If not null, what do? You return whatever is present, correct? Agree with me?
Yes, sir.
Yeah. So in this scenario, whenever someone calls the clone method, by this time already S is available. Let us take that S is available. It will return that object. If it is not available, it will create the object. So, so this is a way, this is one of the way how you can break the singleton design pattern using cloning and how you can fix it. There are some more ways like deserialization. Using deserialization in Java, you can create one more object and multi-threading also. So which we are going to see how to break a singleton design pattern using deserialization, how to break a singleton design pattern using multi-threading, and how to fix it, which we are going to see in the tomorrow class. So what I have explained today is what are the different in the interview they might ask you once you write a code, they might ask you what are the different ways to break the singleton design pattern. That is one way. Or they will say that if you have written a private constructor, they will say that I can write a code using reflection. Then I can call. Then your answer would be, I will write like this. And they might say that I will write a clone method and I can get a new object. Then your answer would be, I will write this code, right? And they may ask you when you're explaining. So what happens if you don't implement a clonable interface? The clone will not happen because JVM does not know that it should implement. Now, whenever you're implementing a clonable interface, does it mean that clone method is present in the clonable interface? No. Why are you overriding it? Because the clone method is present in the object class. It's a protected method. And these packages are different. In order to use a protected method in a different package, you need to override it. Correct? So this is what we learned today. And in the tomorrow class, what we are going to do is we are going to learn how to break the design pattern, singleton design pattern using deserialization and using multi-threading, and then how to fix it. Any questions?
Sir, first time we are overriding the clone method, right? So,
First
but
time,
first time we are overriding the clone method, right? Clone
code
method,
method.
sir.
Yeah, correct.
Clone, yeah. So, for
Yeah.
that, something you are writing, sir.
So yeah, by default, if you override the, see, let's write clone. So
Uh,
let's remove. Okay. Let's go this class. Say where the clone method is present in object class, right?
object class.
So by default, this is the code will come, right? Whenever you override the clone method, by default, the compiler or Eclipse is giving a suggestion like this, correct? Super
Yes,
dot
sir.
clone. That means super means where it will go.
Super class,
Parent
sir.
class, correct? What is the
Uh,
parent class for this?
object class only.
Now it will go to object class and object class clone method it will call, correct?
Yes, sir.
That means what is the implementation in the object class clone method? It doesn't matter. Whatever you do, it will create a new object. Okay.
Sir,
It-
my question is, sir, actually, how to return the just current class object, sir? How
so
to
that is
link?
what, yeah, that is what I see here in the current class, in the clone method. So
Okay.
whether what, for example, if you're calling a parent class also, what object you are creating? This
Main
class only,
class.
correct? Main
Yeah.
class only, correct?
Okay.
Now here, what class your object you are creating in this one? Singleton design
Singleton
pattern.
only.
So that is what I'm doing. What is S? It's a reference variable for this singleton design pattern, correct?
Yes, sir.
So in the clone method, I'm checking if the S equal to null. That means no one has created any object. So I'm creating a object, correct? If already
Not,
someone called the get instance method, then you
sir,
are returning that.
not this code, sir. Previously, sir. Main class method.
Yeah.
Yeah, main class clone method, right?
Mm.
Now current class main class object is returning only, sir. So for
Yeah.
that clone method, sir.
Yeah.
So
Correct.
how link, sir? How to return? How do no clone methods return this main
Yeah.
class?
Because see, whenever you say super dot clone, there is an
Okay.
inheritance relationship between this main class and then
Uh,
object class, correct?
yeah, yes, sir.
It will know. I mean, the JVM will know that from which class you are calling this clone method. Then what it will do? It will see what it is not returning your main class. It is returning a object class. But then can you typecast it to a main class? Yes, because there is an inheritance relationship between main class and the object class, correct?
Yes, sir.
Yeah. So here you can even see instead of object class, you can typecast it. You can write
Okay.
main class also.
Okay.
Okay. And here, whenever you're doing, you can typecast it. By default, the method will give you, see, look at here. By default, the clone method will return object class, correct?
Okay.
But even though if you are putting in a, whenever you are writing a overriding, you can modify the return type, correct?
Yes,
This
sir.
is called covariant return type.
Yeah.
The return type of a child class should be subclass of the parent class, right?
Yeah.
Yeah. So in this way, you can say that it's a returning main class only.
Okay.
Hope that answers.
Yes, yes.
Yeah.
Okay.
Yes, I hope some you learned something new. Those who are
Ye-
watching on YouTube or those who joined today.
I learned from you, sir.
So
Yes, sir.
we'll,
Yeah.
yeah. So we'll continue tomorrow also. The demo classes will be there till Tuesday. If you are interested, you can enroll for the course. I think Rajesh, you can share your feedback, how the classes would be.
Okay, sir.
I think you have joined some of my previous classes, right? Like you.
Uh, Actually, multi-threading and the collections.
So was
I
that
joined.
useful?
Yes, sir. I'm learning new things from the collections and the multi-threading also. Previously, I lot of new things learning and I have cracked the interview also from multi-threading and collection.
Yeah, nice to hear. So I'll be teaching the same way, guys, like complete practical. So
Yes,
if you
that is one more advantage of everything is a practical, everything is writing the code in the print of store for ours.
so if no question, then that's all for today, guys. And we'll
So do
see.
you conduct the class in the evening or
No,
only in the
only
morning?
only in the morning.
Oh, okay.
Okay. So I mean, whether you join or doesn't join, it's secondary. But till the demos are there, you can watch it for free. Uh, let's learn something new, right?
Yeah.
Yeah. Thank you, guys. Thanks for
Yeah.
joining. Have
Thank
a
you.
nice day.
Yeah. Thank you.